Missed out on that one. All right, anyway. So into this one here, you have the sum is less than 8 or the sum is greater than 11. So basically, if you think about the dice part, you're really only worrying about, just for visual here.
Hey, Mr. Murphy.
Yes, sir.
What are on Eric's legs?
His arms. So the sum is less than 8 or greater than 11. So you want anything that's less than 8. So that's going to be, basically you're going to count 8s, 9s, and 10s. Or greater than 11, sorry. In this case here, if you use a complement, it's still a lot of counting no matter what. So if you're looking for sums that are less than 8, that's going to be 7, 6, 5, 4, 3, 2. And a greater than 11 is just going to be 12. A complement, remember, is 1 minus the probability of these occurring. So basically I'm looking at the probability of an 8, 9, 10, or 11. So if I count those, I take 1 minus it, that gives me the other one. Or, at this point, you can just start counting and get the right away. Does that make sense? That's all it is. It's just, it's not the greatest place for a complement. A complement's greater, it's better, like what's the probability of rolling greater than, less than 11? Or then you can just have to count out 3 of them and take the opposite. It's just quicker that way.
Do you have to use a complement, or if it's easy just to count the arrow?
That's what I was getting at. You don't have to use the complement. And you're right, in a case like this, it is pretty easy just to count it straight out because there's not that many of them. Yes, sir.
You do 36 complement or whatever?
Yeah, the sum is greater than or equal to 5. So if I want to do the probability that the sum is greater than or equal to 5, basically I'm looking at doing the opposite of that, less than 5. So I want to look at 1 minus the probability of the sum is less than 5. Well, that's going to be 4s and less. That's 1, 2, 3, 4, 5, 6.
What did you count?
Less than 5.
Oh,
Because I wanted to be greater than or equal to 5, so I'm going to count everything that's less than 5.
okay.
So 4 and below, that gives us, there's only 6 of those. So that means 36 over 36 minus 6 over 36 is? Bless you. That's a prime example of one I would use a complement of. It's a lot less counting. You with? Okay.
I feel like he actually speaks like very fluent Spanish.
Es posible. Yo quiero papa.
That was in the word.
Yo quiero? Yeah. Yo quiero.
I didn't hear him.
Turn the other way. What else you got? Anything good? Alright. Queso, we got queso dip. Make sure your name's trying to set it up. I think we had a little bit left of this one to do, didn't we? A, B, confidence. Yeah, no, we're all right. Let's just go to 5. We'll come back to this.
We use 2 lines for each. I use the whole page instead of full.
And you use like, you got the small or big.
So, probability of independent and dependent events. Yes, ma'am? Yeah, it's somewhere around there. I've been making them. I've been piecemealing it together. I have one definite packet that I'll give to you guys. Actually, no, I'm sorry. I have 2 different ones. It's just a ton of problems, different varieties and styles and things like that. They have answer guides to them. I'll post the answer guides on the websites. I'll post the review guides online as PDFs, so if you lose yours, you can just pull it up and look at it. my guess is that we'll probably be done, so I'm gonna go into 12.5 today. I know there's a little bit of 12.4 left to talk about, not much, but we'll kind of blend that with the word problems in 12.5 tomorrow. Oh, you're just, get out of my classroom. All right, that's it. Have a good afternoon. Yes, sir.
Is the final going to be multiple choice?
Yes, sir.
Nice.
Is it like 50? You don't want to
I think so, yeah, because I just don't want to flip it over.
I like that.
Seriously, I mean, what's the point? It takes too much time. Because if we have to flip it over, it's going to be another 10 questions, and then I have to go back and add.
Might as well just not.
Nobody's got, I don't have time for this adding and stuff.
Why do you have to add?
You have to flip it over.
Gotta
Flipping
flip
it
it
over
over. It
takes a lot
doesn't, it
of
doesn't add both scores on both sides.
It doesn't.
No, that's what I'm talking about. It's more work.
It's just not have a final.
Hey, welcome back.
Oh, thanks.
Good to see you. So, yeah, the final will be 50 minutes. I know that the final times are being adjusted again right now. Not 50 minutes, 50 questions.
It's like 100 minutes now.
Yeah, the reason, I don't know if you guys knew this, but the reason that they had to adjust the times for finals and stuff, because the state of Illinois. The state of Illinois, in their infinite wisdom, because, you know, nothing says, let's mandate educators by people that aren't educators. Makes great choices. They said that you have to have full days of school on the first and last days. I get it, first day, not a big deal, but last day when you're dealing with finals, it kind of, I mean, it's kind of silly. So they had to stretch it. They had to stretch the days a little bit longer to be able to technically have a full day. So our normally our finals were 75 minutes long.
Do they really look at that though? Like, will they catch you?
Yeah, how are they gonna catch it?
There's no budget. I don't know. Talk to the ROE, the office over that way.
ROE.
The Regional Office of Education. The Regional Office of Education takes care of the county of all the different school districts.
We can pretend we're in school.
I'm with you, but they might come after us and take everything away.
Better get along.
So they, just one second here. What happens is that we had to stretch the days longer, so the finals are now 100 minutes long. It doesn't mean that I'm writing the final to take 100 minutes.
I teachers are gonna do that though,
I'm sure they're,
and they're gonna be jerks.
you know.
You know, half my
But
finals are-
also, that also means that the way that I've always done finals, and you guys know this from first semester, is that there's no phones, there's no electronics or anything like that. So you guys will just have to, I think your final is the second day now.
Yeah.
You guys just take a little nap.
That's
Or
why
study for your other finals, quietly.
they have PE.
I know. So, yes, let's see what's first, sorry.
Okay, so you know how we have to be here like for 5 hours?
Yes.
But what if you, like, if you have a study hall, do you just like?
You're only exempt from study hall first and 12th.
Oh, yes. Sweet.
Are you sure?
Yes.
'Cause last year I definitely, last semester I definitely missed 5, 6.
I'm gonna have, don't, yeah, anyway.
That's like the first one of your day or the last one of your day?
Like Mr. Sepp told some of the freshmen that, like last year, you guys just had like a study hall at the end, and then everybody just like left, and they just called it a study hall, but technically we were here, but everybody skipped.
They did, but I don't know if that's how it's, they tried, I don't know if it's kind of, I know where you're going at. Because you're right, that's what we did last year, because technically the buses were still picking up at like 1. So if you had to wait for a bus, you waited for a bus, but if you didn't, I don't know where he went.
Bye-bye.
He just left.
I didn't see him. Where'd he go? Where'd you go? That movie came out 30 years ago yesterday.
Which one?
Top Gun.
Oh yeah, I forgot.
Yes, ma'am.
So like, if I don't have a final
Top
for my
Gun's a
classes,
solid
can I just like walk out? Or is that?
I don't know.
It depends, like, is
Yeah,
it
yeah,
like,
sorry, okay.
so what, isn't it 2,
Pretty
how does it
sure.
go? How does it go? What
It's
are-
1, 2, 3, 4, 5. It's gonna go 1, 2. It's 1, 2, 3, 4, 5, or 5, 6. And then it would be 6, 7, or 7, 8, I believe. And then it would be 8, 9.
It's 2, 2, 3, so it's 2, 2, 3.
Yeah, because they're trying to make the last day longer.
Oh, that's right. So then it'd be 4, 5, 5, 6. So this would be 6, 7, or 7, 8, 9, 10. Then there's no flex, but there's,
And then
12 hours.
and then 12.
So, you wait, so if you have a, yeah, then if you have a study hall like 6, 7, or 7, or 8, then
You
you
know,
could
you're
leave.
at-
But if it was
you're
8,
at-
9, or 9, 10, then you couldn't leave.
I believe so,
If it's
yes.
the first one or the last one you're doing.
I think it's
either
first last,
show
yeah, that
or
makes
leave
more
or
sense,
leave.
first last of the day, yeah.
I only have
'Cause I remember
one
I-
final
So
day.
I definitely missed like a whole day.
Because if you 8, 9, or 9, 10 right in the middle.
So, anyway, let's talk about probability of independent, dependent events. Woohoo! You actually know some of this already because we kind of mingled a little bit within the stuff. Independent. Probability of, guys, probability that two events are going to occur. Probability of A and B occurring. Take the probability of A, and then times the probability of B. For example, flip a coin.
Man.
If I want to do flip a coin and I want to get the probability of going tails, then tails. 2 tails in a row. What's the probability of getting tails on the first flip?
100.
What's the probability of getting tails on the second flip?
Half.
Are they independent of one another?
Yes.
You multiply it together and your probability is 1/4. That's what it is. They're, what's that?
How do you know they're independent?
You're flipping a coin multiple times. You want to flip a coin 4 times, and you want it to go heads, tails, heads, tails. Each one of those flips is an independent event. The probability of getting a heads the first time is a half. The probability of getting tails the second time is a half. The probability of getting heads the third time is a half. The probability of getting heads the fourth or tails the fourth time would be half. 1/2 times 1/2 times 1/2 times 1/2 is 1/16.
Oh, I missed the fourth one.
So that's the idea of
So,
independent events.
so because it's independent, you multiply.
Right.
But if it was like, so you pick it, if you want to, yeah, like we did last.
Yesterday it was a little bit. It was like more of a compound. You
Yeah.
wanted to get.
So if we were
You
getting
got that word or.
a 6, so we're picking like 2 cards. We might stack cards. We're getting like a 6 and a 5.
Uh-huh.
When we do it twice, so it'd be like 1 off 50.
Depends on how it's worded. And I've got a ton of examples that go through there. And this is where it becomes really careful about reading the wording, how it goes. Okay. So if I go back to another one here, let's say we have you're spinning the money wheel. We're doing the Wheel of Fortune. And during your turn, you get to spin the wheel twice. What's the probability that you get more than 500 on your first spin and go bankrupt on your second? Well, you might not be able to read this very well, but if we count,
Do we actually spin it?
of course we spin it. You knew we were going to spin it.
It always
Where does it end?
I don't know.
It doesn't.
It doesn't.
Where do we know where it goes?
We'll say it goes here. I'm on a line.
It's the same.
500.
It's 100. So,
It's always the same.
well then I don't want to go there. I want to go here, $900. Hey! So if I'm looking at, I didn't see it. It was spinning too fast. The probability you get more than $500 in your first spin and then go bankrupt in your second. Basically, you have to just count all the possibles that are there. As you go around it, we're going to have 1 little, 2 little, 3 little spots, 4 little, 5 little, 6
Little
spots,
spots.
7 little, 8 little, 9 little spots, 10 more spots, 11 little, 12 little, 13 little spots, 14 little, 15 little, 16 little spots, 17 little, 18 little, 19. I've lost count.
I think we were at 19.
20, 21, 22, 23, 24. There's 24 little spots going around. What are those spots called?
Wedges.
More specifically, sectors. Very good. They're sectors. Are they equal valued sectors?
No.
Yes.
Yes.
Well,
I hope so.
Well, I would hope so.
How is bankrupt the same as 150?
I'm just saying equal in measure with the angles and stuff. Anyway,
Then yes.
so we have to count then how many of them are greater than 500. Let's
That's
see.
all the A's.
1, 2, 3, 4, 5,
It's all it is.
6, 7, 8.
All right.
All the A's.
It's already marked.
A's.
A's.
1/3.
So I have get more than $500 my first time round. Is the second roll, the second spin, independent of the first?
Yes.
Yeah. So how many bankrupts are there?
2.
There you go. You can simplify first if you want, or just throw it in the calculator and you're done.
Okay, I got it. Not thinking
Let's see. 4, 2, 6, 1, third, 112, 136. Okay. Oh, I didn't change the pictures. No, I forgot to do that. I'll do that later. We'll come back. We'll do this one again. During baseball, 97 baseball season, the Florida Marlins won 5 out of 7 at home, 3 out of 7 away games against the Giants. During the National League Division Series with the Giants, Marlins played the first 2 games at home and then the 3rd game away. The Marlins won all 3 games. What was the probability of that occurring?
But what about, like,
Okay. The question here is talking about, they have a,
In other words, they're good at home, they're bad on the road.
yes,
So the regular season.
in the regular season, yes. So what you're looking at here is you're trying to figure out the probability that they won 3 games in a row, given the fact that they were home and then away. Okay. So you want the idea of, when you think about this, you want to go the probability of 3 events here, A, B, and C. The probability they won game 1, probability they won game 2, the probability they won game 3, given the fact that you had these already set up with, you had some records at home. So you're using some more information, not just a 50-50 chance. Okay. Let's see, what was it? They won all 3 games. The first 2 games were at home. The 3rd game was away. So what's the probability of it winning at home? What was the 5 out of 7? So the probability that they won at home was 5 out of 7. That's game 1. Game 2, 5 out of 7 again. Yep. And then
3 out of 7.
3 out of 7.
They're bad.
It ain't bad.
That's what that, it looks weirder than what it is, and that's how you get these ideas of, I don't want to get into like bookmaking or how odds are working. They're obviously different than probabilities. Odds are, what is it? Odds are, oh, how do you say that? It's the odds are different. Like you have, it's the probability. It's in the book. We just don't talk about it. The odds. Doofus. Yeah. The odds of an event occurring is a ratio of the probability will occur to the ratio the event will not occur.
75
So the odds are different. So you have, if you think about an odds, like if you're a 4-to-1 favorite, that's the probability that you're gonna win versus the probability you're not gonna win. That's what those mean in terms of fractions and all that junk. Yes, ma'am.
You get the other 5 out of 7.
odds, like, first.
These were home
Yeah,
games.
no.
First 2 were at home, so it's just using the home record. 5 out of 7.
Oh.
That's where that comes from. Okay. I'm going to try and stay away from the ones that deal with combinations and permutations with independent, dependent. We can do them. We're just kind of running out of time to really get into them. So we're just going to kind of scratch the surface, if you will, on some of these probabilities and not get too fancy. Probability of a dependent event is when you're talking about the probability of one thing occurring and the next thing happening after that first one occurred. And this is our lottery problem. This is our lottery problem. If you think about the lottery problem, the probability of, let's just say it's the what's the Powerball game? We've been running the Powerball for a while, and I know you guys know how this is working. In the Powerball simulator that I'm running, there's 55 numbers. The probability in the first one is 1 out of 55. Now, the probability of the next one I'm going to get, because that first ball doesn't go back in, is going to be 1 out of, and that's how these dependent events are occurring. Generally speaking, your denominator is, it's what we call without replacement. It's not going back into the hopper. You're not picking that out, putting it back in. You're keeping that one out. So your denominators are going to change. 1 out of 53. Oops. 1 out of 52, 1 out of 51. Was it 5 numbers and then the Powerball? And then we just redid it like that. So you've seen this before because you wanted something already to occur. So the idea here is we can take a dependent event and write it as, well, what's the probability of picking a 5, then a 6? I'm going to say without replacement.
Without replacement. Ooh.
I'm not putting the first card back in the deck. So if I'm going to pick a 5, what's the probability of picking a 5 out of a deck of cards? 4 out of
Wait, are we
52.
doing deck of cards or Powerball?
I'm going 4 out of deck of cards, sorry.
Alright.
That card, whatever card I didn't get, or whatever card I picked, does not go back in the hopper, so now what's the probability of getting a 6?
You keep saying hopper. And then
Oh, I mean in the deck, whatever.
Shuffler.
It's not even a thing.
That's how these work. It's not getting placed back into it. So it's what we call with and then without replacement. If I replace the 5, what's the probability of getting a 6?
4 out of 52. 4 out of 52.
4 out of 52. So those become independent draws of one another because you're starting with the same amount of cards in the deck. The dependency comes into play because you've already taken one out and you're not placing it back in. Does that make a little bit of sense? So you're going to see a lot of terms where it says with and without replacement. Yes.
So how do you know the difference between dependent and independent event?
It'll say with or without replacement. A lot of times with decks of cards, it'll say with or without replacement. And other times it'll say providing that something already had occurred.
So like without replacement is dependent, and then with replacement is
Yes, and let me read you an example from the book, and you'll start to pick up on how they word it. So let's see. You randomly select 2 cards from a standard deck. What is the probability that the first card is not a face card, and the second card is a face card if A, you replace the first card before selecting the second, or B, you do not replace the first card?
so the first one would be the second
Correct. And a lot of them are going to be worded quite literally like that, where you're going to have to do 2 parts of it, one independent, one dependent, because they'll throw in the terminology in there with or without replacement. Does that help that a little bit?
Yeah.
Yay. You and your friends go to a restaurant and order a sandwich. The menu has 10 types of sandwiches. Each of you is equally likely to order any type. What is the probability that each of you order a different type? How many sandwiches are there?
Well, it's highly likely because no one wants the same sandwich. So if someone
If
orders,
you order the same thing as the guy next to you,
you might as well shoot something.
So
well, you always ask me.
you're going to order a sandwich, right? What's the probability you're going to order a
At
sandwich?
least it's staggered.
Pretty good.
Like 100%.
Right. So how many sandwiches are there to choose from?
10 good.
So the first person to pick a sandwich, just want to say sandwich, is 10 out of 10 because that person, he or she, is going to order a sandwich. Right?
Yeah.
Well, what if they don't want to say?
So there's one. I ordered a sandwich, I win. Now Bethany, you're going to order a sandwich, but you're not going to order what I ordered. How many sandwiches do you have to choose from? Out of how many sandwiches? There's still 10 of them, right? Psalms. You did not like what either of us had, but yet you didn't know what either of us had. So how many sandwiches are left?
I got jumped in the room.
Go for it.
It's just like
I'll take the fake girl.
Oh, you're trying to do permutation, combination stuff?
Real cheese.
Ruben's
Second on 1, second on 2.
It's not going to factorial itself
I'm the one.
because there's only 3.
No.
One pick it.
Second on this.
3 people win.
I
Oh,
just make fun of
Okay.
myself.
If there were more people, then you could continue on that, but it was just, the way it was worded was just 3 people had a sandwich. And 3 people did want the same sandwich. Just want to say sandwich.
Sharing. Sharing.
So hopefully you can probably do this one in your head. Thanks, Mel. I appreciate the enthusiasm, and I didn't kill you with that one. You got time. We got a couple weeks to work on your calluses.
Oh, I got that. They're not feeling too good. I peel them all. Eventually.
Oh, it's this one. Mine is this one. Conditional probability. This is a little bit different. This is when you're going to look at a table and you're going to read about what they're asking. The table shows the number of endangered and threatened animal species in the United States as of November 30th, 1998. Good data set for us, right? All right. It's only been a few years.
Okay.
Wow. Hey, I can't make this bad joke next year because we'll have a new book.
What's that joke?
Still
Does that mean we can take our books home?
I don't know.
I'm gonna burn them.
I'll take everyone's.
So, back in the day, I'm sure this list has probably been updated, and I bet you there's a lot more endangered or threatened species in America. So the first thing we do is find the probability that a listed animal is a reptile. So what we do is we look at our list and count how many of them are reptiles.
Why aren't fish on?
They're probably under the other category, Kobe.
I see reptiles there. How many reptiles are on this list?
35.
There are 35 reptiles on this list. Out of how many animals on this list?
A lot.
Lots of them. Okay, there's your probability. Well, you can add that up. I'm hoping your thumbs are somewhat normal. 475?
Find the probability that a listed animal is a reptile.
Now the next one is find the probability that the endangered animal is a reptile. Which one are you looking at?
The top one.
I'm looking at 14 out of all of the endangered animals. So this goes back to being able to read a question and get information from a table. Whereas you're just looking at the endangered as opposed to the listed total animals. It's a data set table that you've probably read many times when you're in science or some other class at some other point in time. What's that? Was it 475?
So does the next one become 474?
No, because you're looking at just endangered. So you just count, you're just adding up this list. For the endangered? Thank you. No, this is two different parts. This is part A, this is part B.
Are we done?
Yeah, I kind of think so.
Yay.
There you go. Not much to this one.
Oh no.
I was Googling the whole time.
Probability stuff?
Yeah.
Hey,
They go into some of the books. To be. Oh, do 32 also. 31 and 32.
yeah, I know, I've kind of switched.